Okay, as promised, we're going to talk about compound interest now, because this is one of the major applications of exponents and exponential functions. Okay, let's start with an example. Suppose you invest $1,000 at 10% simple interest for 5 years. What simple interest means is that each year you just earn 10% of the $1,000 that you invested, which would be 10% of 1,000 would be 100. So you'd be earning $100 for each of those 5 years. So at the end of the 5 years, you'd have $1,500. The 1,000 that you started with plus the 500 that got added on as interest. But with compound interest, you get to earn interest on not just the amount you started with, but also on the interest that you've already earned. So suppose you invest $1,000 at 10% interest for 5 years, compounded yearly. That means that after 1 year, you've earned $1,000, or you have $1,000 plus you earn 10% of that, which would be $100, which means that at the end of that 1 year, you have $1,100. But for the second year, you get to be earning interest not on the $1,000 that you started with, but on the $1,100 that you had at the end of year one. So for that second year, you earn 10% of $1,100, which is $110, which brings you up to $1,210. For the third year, the interest that you earn is 10% of that amount. So $121 gets added on, which brings you up to $1,331. For the fourth year, the interest you earn is 10% of that amount. So that gets added on and brings you up to $1,464.10. And for the fifth year, you earn 10% of that. So that gets added on and brings you up to $1,610.51. So remember, with simple interest, you ended up with $1,500 at the end of 5 years. With compound interest, you end up with $1,610.51. So with each year, you added on whatever percent of the amount you started with, and that's the same as multiplying by 1 plus that interest rate. So after t number of years, you multiplied by 1 plus r t times, by t factors of 1 plus r, so you ended up with p times 1 plus r to the t. In that example, it was 1,000 times 1 plus 0.10 to the 5 power. But instead of earning interest in one big lump at the end of the year, 10% a year would be equivalent to 5% for each half of the year. Like, instead of earning 10% at the end of the year, what if you earned 5% for the first half year and then another 5% for the second half of the year? Under that scheme, after half of a year, you'd earn 5% of the amount you started with, which would be $50, which would bring you up to $1,050. After another half year goes by, so at the end of one full year, you earn 5% of what you had at the end of half a year, which is $5,250, and that brings you up to $1,102.50. After another half of a year goes by, you've earned 5% of that, which brings you up to $1,157.625, and so on. So you keep adding on 5%, or multiplying by 1.05 for each half of a year. That's 10 times in all over the course of 5 years. Remember, a dollar amount plus 5% of that dollar amount is like that dollar amount times 1 plus that dollar amount times 0.05. So if you're multiplying by 1 plus 0.05, that's the same as multiplying by 1.05. And you do that for each time the interest gets compounded, that is for each half year. And since there are 10 half years in that 5-year period, altogether, you're multiplying by 1.05 10 times, by 1.05 to the 10th power. So the general formula here, and all of this gobbledygook that I've been saying so far, the examples we've been going through, is to try to justify that general formula and explain why it works. So the general formula is, if you start with P dollars and you compound in times per year at an interest rate of R, and you do that for T years, the amount you end up with at the end of that time is given by this formula, A equals P times the quantity 1 plus R over N to the N times T power. So if you start with $1,000 at 10% interest for 5 years, compounded yearly, well, we've already seen what you get, but let's try it on that formula. So in the formula, the P stands for the principal or present value. That's the amount of money you start with. And in this example, it's 1,000. The R stands for the interest rate, but you have to put it in as a percent. So a 10% interest rate would go in as 0.10 for R in the formula. The N is the number of times per year the interest is compounded, and the T is the time, the number of years. So if we're compounding yearly, that's just once a year, N would be 1, and the formula would be 1,000 times, in parentheses, 1 plus 0.10 divided by 1 to the 1 times 5 power. And that gives you $1,610.51. Compounded twice a year, same formula, but this time N is 2. So I'm just going to go back and edit this to change the 2 instances of N in the formula from 1 to 2. And we end up with $1,628.89 approximately, if you round to the nearest cent. What if the interest is compounded 12 times a year? So monthly would be 12 times a year. So now the number we put in for N is 12. We're evaluating 1,000 times, in parentheses, 1 plus 0.10 divided by 12 to the, in parentheses, 12 times 5 power. And that comes out as $1,645.30 if we round to the nearest cent, 2 places after the decimal point. What if it's compounded 360 times a year? That's almost daily. So go back and change the formula so that N is 360 instead of 12. And it gives us $1,648.61. Okay, what if it's compounded 36,000 times a year? Then the formula, when we plug in 36,000 for N, so 1,000 times 1 plus 0.10 divided by 36,000 to the, in parentheses, 36,000 times 5 power, we get $1,648.72. Okay, that was bigger, but not by much, just 12 cents compared to 360 times per year. So it looks like the more times per year the interest gets compounded, the higher the overall amount, but there is a limit to how high it gets. It gets higher the bigger n is, but at some point it only gets a little bit higher. There's a limit to how big that gets. So if we put in some really, really huge number for n, some number that's up close to infinity, the number we get out wouldn't be infinity. It would be not very much more than what we're seeing right here when we put in 36,000. So like if I went 1,000 times 1 plus 0.10 over, say, a million, 1,000,000 to the 1,000,000 times 5 power. So I put in a million for n. I get 1648.721229. Not much bigger than what I got when I put in 36,000. So as the n gets bigger and bigger, the values you get out of this formula just get closer and closer to some particular number. And so that sort of limit is what we call compounding continuously. That would be like if n, the number of times per year you could compound, was infinity, or just a really, really big number. The amount you end up with, we say that's what you get when you compound continuously. And the formula for that is, for continuous compounding, A equals P times e to the RT. So that's basically what the first formula would give you if you could plug in infinity for n. So here that would be 1,000 for P times e to the, in parentheses, R was 0.10 and T was 5. So we get 1,648.721271. So to the nearest cent, it's still just $100,648.72. Okay, a couple more examples. Find the amount that results if $300 is invested at 7.5% interest for 4 years, compounded quarterly. Okay, which formula is it? Compounded quarterly would be 4 times per year. So the first formula with 4 for n. P is the 300 you start with. R is the interest rate, but in decimal form, 0.075. Remember to convert between percents and decimals. You always move the decimal point 2 places. N is 4 because compounded quarterly means 4 times a year. And T is also 4 because we're talking about 4 years. So when we evaluate this expression, and try doing this yourself on your calculator and make sure you end up with, rounded to the nearest cent, $403.83. How about this one? Find the amount that results when $500 is invested at 6.7% interest for 6 years, compounded continuously. Okay, which formula are we using? This time it's the second one, the one for continuous compounding. A equals P times e to the RT. So the P is the amount we start with, $500. The R is the interest rate, but as a decimal. And the T is the time, the number of years. So A equals 500 times e to the 0.067 times 6. And that comes out of the calculator as $747.51. Try that for yourself. And if that's not the number you get, figure out why or ask me for help.